I am Tanuja Subba, Assistant Professor from the Department of Computer Science and Engineering. I would like to again welcome all of us to this faculty development program on artificial intelligence in remote sensing and Earth observation. I'd like to welcome Mr. Pranay Pradhan and Ms. Priya Pradhan. Pranay Pradhan, specially as the speaker of today's session. I'd like to request Dr. Singh sir to present our guest with a khada and a memento. Thank you, sir. It is my privilege to introduce Mr. Pranay Pradhan. He is an Assistant Scientific Officer, Sikkim State Council of Science and Technology, Government of Sikkim. He has pursued his post-graduation in Geography in the year of 2005 and MPhil in Remote Sensing and GIS application in the year of 2007. He has worked on many projects in North Bengal University for environmental impact assessment of Medadechu hydroelectric project Bhutan in the year of 2008 to 2009. In the same year, he joined State Remote Sensing Application Center under DST Government of Sikkim. He has worked as Junior Research Fellow in the year of 2009 to 2012, where his projects are under preparation of landslide database center in Sikkim, snow cover mapping and monitoring of Sikkim Himalaya. Since the year of 2012 to 2015, he has worked as project scientist and studied of glacial dynamics of East Rathong Glacier, West Sikkim. In the year of 2015 to 2022, he has worked as Scientist B on National Mission for Sustaining the Himalayan Ecosystem and had worked on the study of climate change and its impact in Sikkim. Since then, till date, he has been working as Assistant Scientific Officer, where his roles and responsibilities is to look the existing projects in the center, and his main focus is on studying of glacier and glacial hazards. We would like to welcome you, sir, and thank you for accepting our invitation. Without further delay, I'd like to call upon Mr. Pranay Pradhan on the dais for the talk.
So actually, dear participants, along with Mr. Pranay Pradhan, Mrs. Priya Pradhan will be also joining the sessions. And now I request Palasar to offer khada and memento to Ms. Priya Pradhan.
I'm Pranay Pradhan. I'm working as Assistant Scientific Officer in Sikkim State Council of Science and Technology under Science and Technology Department. I'm working in Science and Technology Department from the year 2009. And recently, in 2020, I got observed in Sikkim State Council of Science and Technology. So I will start my presentation. Before going to our main presentation, I just like to give a short background of our department. Our Science and Technology Department, it is also known by the name Vigyan Bhavan. It is located in Deurali, Gangtok. Our department is very new department. It is only established in the year 1996. And the department is headed by secretary. Below secretary, there are directors, scientific officer, assistant scientific officers, and resource assistant. And the DST department is completely comes under the state government. And the main objectives of our department is to promote science and technology in our state. Under DST, Sikkim State Council of Science and Technology is also established in the year 1997. And the main function, main role of the State Council is to, it works as a working arm of DST, Science and Technology. That means all the projects and research work is carried out by the Sikkim State Council of Science and Technology. And all the administration kind of things, it's looked after by the Department of Science and Technology. And this council is actually established in all the states by Department of Science and Technology, Government of India. The council is headed by member secretary, and below member secretary there are directors, scientific officers, assistant scientific officers, research assistant, and project staff. And the project staffs are basically they recruited in the project basis, and it's completely supported by DST, Government of India. And in our DST, there are main three divisions. That is State Remote Sensing Application Center and Climate Change. And another one is Biotechnology Department. Biotechnology technology division, they mainly look after the plant-related studies. And Technology Transfer Division, there are three divisions. And Sikkim State Remote Sensing Application Center, it works on the application area of the remote sensing in Sikkim. We work on the project funded by state government, central government, and external funding agencies like international funding agencies, GIS, Swiss Development Corporation, etc. Our major work focus on the glacier and climate change. So climate change added as an additional responsibility. So most of the projects we are doing in our councils are basically based in climate change studies. So now our remote sensing center is also climate change. We are also working on the climate change. So we have a major collaboration with NRSC Hyderabad, Space Application Center Ahmedabad, NISAC Shillong, and DST, Government of India. Our main responsibility of our remote sensing application center is we are working on application of space-based project in Sikkim. All the space-based projects for the state of Sikkim we are carrying on. So preparation and updation of important layer of map. Whatever the important maps of the states are there, like road maps, drainage map, glaciers map, land use map, whatever maps are there, we used to prepare or update the map. And we are also preparing village level maps for Panchayat. Since we are the nodal department or division for the remote sensing related activities, all the mapping, small state maps, district map, subdivision map, district map, even ward Panchayat level, we used to prepare all those maps. And we used to provide the maps to the Panchayat. And we are also provide remote sensing and GIS based training programs to our state government officials and the students. And we also help students, research scholars, in remote sensing and GIS based projects. So these are the few background of our State Remote Sensing Application Center. And today we are, Miss Priya Pradhan is also with us, and she will going to present on the activities of our Remote Sensing Application Center. After our presentation, I will going to start. I will going to my present on whatever works. As I have already told you all that our main work is focused on climate change. So since 2009, after joining to this our department, I along with my friends, we are basically work in glaciers. And now, as all of you know that the last year there was a GLOF events happen in our state. So we are working on glaciers and glacier hazard from so many years, from 2009 or 10 onwards. So I will going to present on that. So whatever remote sensing approaches we are following, and field-based approach also, I am going to present in my presentation. So before that, Ms. Priya Pradhan will present on the activities of Remote Sensing Application Center.
Good afternoon, everyone. My name is Priya Pradhan. I am research assistant in Department of Science and Technology, Government of Sikkim. Today, I am here to highlight various activities carried out by Sikkim State Remote Sensing Application Center using remote sensing and GIS in Sikkim. We have worked in different aspects using these technologies, like for environment monitoring, site suitability analysis, disaster management, and many more, which we will be discussing in further slides. So, before diving into the applications, let me give you a brief overview of what remote sensing and GIS is. So, like remote sensing, it involves the use of satellite or aerial imagery in like data collection and all. And GIS is like it involves the analysis and mapping of the spatial data. Okay, that is the difference between remote sensing and GIS. So with this base, we'll move towards the application of remote sensing and GIS, which our department has done. Okay. Like in Sikkim, these technologies have been leveraged to solve key issues like it ranges from landslide, forest fire, forest site mapping to agriculture and healthcare management. Okay. So, as Pranay sir has already said, like our Sikkim State Remote Sensing Application Center, it was established in the year 1997 with the main role in promoting the use of remote sensing and GIS technologies for sustainable development, and it operates under Department of Science and Technology. So, coming to the application part, one of the key applications of remote sensing and GIS in Sikkim is the mapping and management of landslide, which are common hazard in our state. Okay, so here what we have done is we have used a high resolution satellite imagery to mark the landslide in our state. Here, like constants mapping are also done, which are the factors that contribute to landslide. Here we have used LIS4 imagery, and this is the work done in the year 2006. So So that landslide inventory we did in the year 2006, and this SILAS, which is Satellite Integrated Landslide Assessment and Alternate System, like this we have recently conducted, that is in the year 2023-24. Here what we have done is like this project, basically we use the artificial intelligence technology. Like what we have done here is we use post-monsoon and pre-monsoon imagery of that particular year, and what we did is we have uploaded those imagery into a tool landslide detecting tool, which is developed by NRSC Hyderabad, and as an output what we got is like the landslide area. Okay, so this is one of a type in which we have used artificial intelligence. Next is like we have also used remote sensing and GIS in site suitability analysis, which is for sericulture development. Sericulture or like silk farming is an important economic activity. Okay, by leveraging remote sensing and GIS, we have identified suitable areas for sericulture development. For here what we have done is like we have used wasteland layer as our foundation layer, and here we have also took into consideration the climatic factor, soil characteristics, and geographic factor, like what is suitable, what type of soil is suitable for mulberry cultivation and all. We have to all those under consideration, and like a site suitability map was developed. This site suitability map is created guiding suitable sericulture practice. Okay. So we have conducted this for the West District of Sikkim. And similarly, for site suitability analysis, we have conducted for kiwi plantation, that is in the East District of Sikkim. Here also similar approach has been taken as that of sericulture. Next, we have also worked for National Wetland Inventory and Assessment. Here, we have used these 3 satellite imagery for mapping the wetlands in Sikkim, where we have mapped 272 wetlands and 281 smaller wetlands that is under 2.25 hectares. And this mapping we have done in the scale of 1:50,000. And we have also published this Wetland Atlas of Sikkim in the year 2018. Next, desertification. We have also worked for this desertification. Desertification is like it's caused by wasteland, fallow lands, and if like a land is overexploited, then that leads to soil erosion and sedimentation. So these are the maps which we prepared. Like there are some particular procedures we need to follow. So following that, we have prepared this map of desertification. And next one is LULC, Land Use Land Cover Change of Sikkim. This map is of the year 2011-2015. So here the red patches which we are seeing here, it is the change, those are the change in area of that particular land use pattern. Okay, so from 2011 to 2015, these red patches, the area of those patches has been changed of that particular land use. So similar to that LULC, land use land cover, we have a much advanced version, that is space-based information system for decentralized planning. as sir he was telling about, like we work in the grassroots levels. So this is the example of that SysDP. So here what we do is like decentralized planning. Like decentralized planning is crucial for localized governance. Okay, so remote sensing and GIS technologies are playing an essential role in supporting this process in Sikkim. So through this SDP project, using high resolution satellite imagery, that is, it's a merged, here we use the merged imagery of LEAS 4 and Cartosat. So using those satellite imagery, different thematic layers, that is EduLC layer, drainage layer, road maps and infrastructure were created to assist in decision making at grassroots levels. So this ensures the planning is more targeted and suited to the local needs of the community. So this is the LULC map which we have prepared in 1:10,000 scale, and similarly there is a drainage and lake map of Sikkim which we have also done in 1:10,000 scale. So coming to next, we have also worked for this forest cover dynamics and human-wildlife conflict. Here, like as we know, forest cover in Sikkim is continuously changing due to both natural and anthropogenic activities. So here we have prepared a forest type map of Sikkim, and we have also identified human-wildlife conflict by ground survey, field survey, and this data is critical for identifying wildlife corridors and areas where human-wildlife conflicts may arise, aiding to conservation efforts. So these are the human-wildlife conflict points. The black dot there, it shows the conflict points, and in the next map we can see that we have denoted some possible corridor points, so we can further study and we can develop. So next we have also worked on integrated watershed management system. In the realm of this watershed management, remote sensing and GIS are invaluable tools for tracking changes in land use cover, vegetation health and water resources. So we use this spatial analysis to map watershed boundaries, land use and soil characteristics. Okay. Monitoring of this variables through satellite data helps in assessing the health of watershed and planning integrated water resource management strategies. Next is glacier studies of basins in Sikkim and Bhutan region under Brahmaputra basin. So Sikkim, it is located in the eastern Himalayan region, and it is home to numerous glaciers. Using this high resolution satellite data, we accurately map glaciers boundaries, which allows us to monitor glacier change over time. It is critical for understanding the impact of glacial retreat, such as the formation of glacial lakes and the associated risk of glacial lake outburst floods. So this monitoring helps in disaster preparedness and environmental conservation. So here, these are the maps showing the glacial lakes, glacier and glacial lakes of Sikkim in the year 2011 and 2021. So in this.
Cancel. You can cancel. There is from the city.
So based on those research, this is the tabular representation. Here we can see that here in this table, in this graph, we can see that the lake area has been changed significantly in since 2011 to 2021, that is in a decade. In the first place comes from Cho, we can see that in the year 2011 it was 175.4 hectares, and in 2021 it has increased 5 hectares, that is 180.5. And similarly, these are the lakes which has increased in area significantly. Glacier monitoring and bluff risk assessment. As part of ongoing efforts to monitor glaciers in Sikkim, we have been compiling an inventory of glacier lakes and tracking their growth. Over the past decade, as we saw here, several lakes have expanded, increasing the risk of bluff. We have identified high-risk category A lakes, which Pranay sir will be talking about later. Okay. So, to reduce the disaster that will be caused, we are planning to install two early warning system, to develop two early warning system for reducing the potential damages that can be caused by flood. So, it has been planned to be installed in Yoksam and other in South Lunak. The other aspect which we work is in forest fire. Here, like forest fire are also a major risk in Sikkim especially during the dry season. So, to combat this, we are developing a fire spread model using this high performance computing system, and by collecting meteorological data, terrain information and fuel characteristics, we simulate this fire spread scenario, and this model helps improve fire management strategies by enabling early detection and rapid response. So next is like in healthcare, we have developed a mobile app named Swastaman app. So this app is available in App Play Store, so you can download it. And what we have done here is like through the development of this mobile app Swastaman, we provide telemedical support that connects patients with healthcare professionals for consultations. This app also helps identify nearest healthcare facilities, expanding healthcare access to underserved communities. So, it is a step towards providing healthcare equity in the region. We have done this in collaboration with Health Department, and it was sponsored by NISAC Shillong. And in this app, you can also do a self-assessment test for yourself, self-assessment for mental health. You can download and you can browse through it. So another topic is geotagging and monitoring of projects that is funded by Government of Sikkim. So these geospatial technologies are also being used to monitor the progress of government-funded projects in the state, that is Sikkim. So by recording the exact location of the project site using GPS or any mobile app, we create a geospatial database to store project information. So what does this do is like this allows us to track project progress, visualize it through interactive dashboards, and ensure transparency and accountability in developmental works. So another aspect is in agricultural aspect. So here application of space technology for agriculture assessment in northeastern region. The project name is ASAN. The ASAN project is a prime example of how satellite data is revolutionizing this agriculture in Sikkim. Okay. By monitoring crop acreage, analyzing agricultural practices, and providing insight into soil health and irrigation, we help farmers make data-driven decisions. These are some of the screenshots of the mobile app ASAN. So this in turn leads to better crop yield, protection, more effective land use, and improved agriculture planning. So this is also we did under NESAT Shillong. Next is sectoral vulnerability assessment, understanding climate change impact. So climate change is already having a noticeable impact on Sikkim from changing rainfall patterns to shifting in agricultural productivity. Through sectoral vulnerability assessment, we analyze these 6 key sectors, namely agriculture, socio-economic, disaster, forest, health, and gender. Like we have identified sector-specific indicators, and we have made this vulnerability assessment. So, in case of agriculture, the most vulnerable district is East, as per the specific indicators that we have taken. And in case of socio-economic, it is the most vulnerable district is North, and for disaster, it is South, the most vulnerable district. For forest, the most vulnerable district is South. Similarly, for health, it is West, and for gender, it is West, the most vulnerable districts. So, with this sector-specific indicators, we have created this vulnerable assessment of the 6 sectors. So, coming to next, climate change risk assessment of Sikkim. We have conducted a comprehensive climate change risk assessment for Sikkim, analyzing historical wetness and dryness across the state, that is from 1970 to 2019, projecting future change in climate pattern, that is from 2031 to 2080. So these projections under different scenario, that is RCP 8.5 and 4.5. These are under the IPCC guidelines. So these are crucial for understanding potential shifts in rainfall and temperature, which can help us plan for climate resilient infrastructure and agriculture in future. So this in the historical assessment, we can see that the driest district is South, the wettest is West, and in future prediction, where we have considered RCP, that is representative concentration pathway 8.5 scenario, the wettest is South and the driest is North. And similarly, when we did this under a different scenario, that is RCP 4.5, we got that the wettest is in West district and the driest is in North district. So next, we have also worked in alpine ecosystem research, that is Shri project. So this project studies the tree species in Sikkim Himalayas, focusing on their morphology and phenology. We use satellite data to monitor how these species are responding to environmental change, helping us understand the overall health of alpine ecosystem. Here we have done the LULC, land use land cover change, for the year 1987 and 2008 of the alpine region. And next is bathymetric survey of vulnerable glacier lakes. So Pranay sir will be talking about this in detail. So like as a part of our ongoing environmental research, we are conducting bathymetric survey of vulnerable glacial lakes. So we have conducted bathymetric survey in most of the vulnerable lakes, which so we'll be talking about it in detail. So next is like we have also installed 70 automatic weather station in the state. Here like 70 automatic weather station has been installed all over Sikkim for creating a better meteorological data for the state. We have installed this in different schools in different districts. So this is the long-term monitoring of East Rathong Glacier. We are tracking East Rathong Glacier using time series satellite imagery, and we are also going there for field survey and all. So this also Pranay sir will be talking about in more detail way. So thank you.
Good afternoon once again. Now, in my presentations, I have lots of slides, but don't feel bored because I have not put too much technical thing in my presentation. I have just put lots of photographs so that it will be not going to be very boring. No? So, and this AI technology, it's very powerful as well as useful. I only know the importance of AI by using ChatGPT. No, it's so powerful. Actually, we are supposed to be the participant here. But anyway, next time we will be joining as a participant. No? So now I will going to take you all to the high altitude area of Sikkim. I think most of you are from the town area, plain areas. Now I will, few of them are from the state. No, I will going to take all of you to the high altitude areas. So whatever, as I've already told you, that most of our projects focus on climate change studies. In climate change studies, glaciers are considered as one of the good indicators to study the climate change. So in our department, we are basically focusing on glaciers studies. So now, as you know, the glacier hazard is increasing a lot. So we are also focusing on the glacier studies, glacier hazard studies. So with that, I just want to start my presentation. The study of glacier and glacier hazard in Sikkim. It's a remote sensing as well as field. Actually, this we are doing remote sensing, but as long as we do not do the ground truthing, field verification, the remote sensing will not be complete. So that's why field studies is very important. No? As I've already told you that we are basically focused on climate change studies, and all of you know that what climate change is. Global temperature is going increasing year after another. So every year the new records is making. No? Every year it's going to hottest and hottest every year. So, and the future prediction also shows that there will be more warm in the coming days. No? So impact of climate change, it's not needless to say that cyclones, drought, ice melting, flooding is happening everywhere, forest fire, it's a burning topic. The country like US is suffering a lot, sea level is rising, so no need to tell all about this. But what actually climate change is impacting is that what it is causing, that frequency of this kind of natural hazard is increasing. Actually, the natural hazard was there before climate change scenario also. The landslide in village, it's a common. But now the frequency of all these events is increasing. That's why climate change is very important. The study of climate change is very important. You can see that the glaciers are melting very, very fast. It's not only happening in our state, it's happening all around the world. And Sikkim being a hilly state, we are suffering a lot than other states. Last year only, Govt happened in our state. That South Lona Lake has burst and it has caused a lot of destruction in the downstream area of the South Lona Lake. So this sort of things is neglected. It's not necessary. Temperature is increasing, vector-borne diseases are increasing, drying of springs. It has caused a lot of problem especially in rural areas, especially in the dry season, winter season. There are a lot of water crises in our villages. So agriculture production is decreasing because of high rainfall, drought, and everything. So migration has increased. So roads are closing frequently. All of you know that. This is not and the main drawback drawback in study of climate change is the lack of data. There are a lot of lack of data in our state. As long as we do not have the comparative data, we are not able to study the climate change properly. So data or lack of data is one of the important things we are facing. So in that scenario, we are already lacking in data. So glaciers, they play an important role in understanding the impact of climate change. Why glacier? Already I have told you that it's a good indicator of climate change because when the temperature drops, ice water get converted into it freezes. And what if the temperature increases? Water melts and so glacier is a good indicator of climate change. Small shift in temperature. Either if the temperature decreases, glaciers used to area of the glaciers or snow is going to increase. So this slide shows the comparative studies of our glaciers from 1990 to 2013. Lots of glaciers in our state is melting, or it is depleting, or it's just vanishing. The red dot shows the area we lost in Sikkim. And this is the way we used to prepare the glacier inventory of the glaciers in Sikkim. Now, I am going to present on what we are doing in East Raton Glacier. It is located in the West District. This is the location of our East Raton Glacier. Actually, the East Raton Glacier is identified as one of the glaciers for long-term study by DST Government of India. So, with the funding of DST Government of India, we have initiated the study in East Raton Glaciers. So, being a remote sensing center, we used to monitor the glaciers by going through or by comparing through different satellite imageries. And as I already told you that until and unless we do not do the field verification, field truthing, so remote sensing will not solve the purpose. And the studies of glacier in the field, it's a very, very one of the toughest job. It's a very difficult to carry out the glaciers studies in the field. In Sikkim, most of the glaciers are in very remote locations. Most of the glaciers we have to track a lot. East Raton Glacier, you can see here, no? This is East Raton Glacier. We are walking here. So this is the view of East Raton Glacier when we see from the paling. So this is the Raton Glacier. So we have to track for almost 3 days to reach the glaciers by foot. So it's a very toughest job to walk on the glaciers. Till Yeoksum, we used to go to the Yeoksum by vehicle. From Yeoksum, In day one, we can reach to Choka, and second days we reach Jongri, and third day we reach HMI base camp. And in the fourth days again we have to trek for 2 hours to reach the glacier actual field area. And in glaciers we have to walk all the days. So these are the Choka. Second day halt is Jongri, it is in 3900 meters. Fourth one is HMI base camp, Stratham Glacier. And these are the ponies. We used to carry the whatever things we required in our expedition, we used to take with the help of ponies. And this is the photographs of HMI base camp. Here is the HMI base camp. From there, that HMI base camp, we used to go to the glacier. This is the close view of HMI base camp. As I already told, walking in ice entire day is very challenging. We have to walk on the surface of the glacier. It's very chilling, it's very cold, and the weather, actually the glaciers study doing in the ablation. Ablation season means the period between July to September. This is the only window when we have where we can study the glaciers, because it's not possible to study glaciers in winter. It's in winter it's very cold. That is the window period, no ablation period. The period between July to September is only feasible time to walk in the glaciers. But that time it's a monsoon season. There will be lots of rainfall in the glaciers also. So it's a very difficult to walk. So what we are doing in Stratham Glacier is different kind of studies, vertical melting studies, in what rate the glaciers is retreating, vertically as well as horizontally. Horizontally means from snout towards the glacier, and vertically means the surface thinning studies. So for surface thinning studies, we used this drilling machines. So glaciers are very massive. Now when we see the glaciers and through the satellite images, it doesn't look so much massive, no? But when we reach to the glaciers and when we see from the close, it's really very massive. You can see here, no? And HMI base camp, no, where their trainees, the mountaineering course take place in the HMI base glaciers. They are the mountaineering students. They are doing training in the glaciers. So we are taking the studies like geodetic mass balance studies, vertical melting. I have already told you, glacier flow velocity. In what rate glacier is moving? As glacier is moving on the gravity, no? So at what rate glacier is flowing? We used to do the monitoring of glacier is now glacier hydrology. We have placed one discharge station. We used to measure the discharge there, and in hydrology study we used to do the discharge as well as the suspended sediment load studies on glacier meteorology studies. So this is the mass balance study we used to carry in field as well as through remote sensing techniques. This is the stakes, bamboo stick we used to install in our glacier. By installing these stakes, we used to do the studies of vertical melting and glacier velocity studies. These are the stakes. One complete stakes is all about there are 7 to 8 stakes are there in one bundle of stakes. So it ranges from 7 to 8 meters. This is UK string drilling machine. It will help to drill the surface of the glaciers. Actually, earlier in the absence of this UK drilling machines, it was very difficult job to drill the glacier. We used to do the manually, no? These are the pipes we used to we used to drill with the help of pipes. It was very difficult job. But after we got the UK drilling machine, we are able to drill about 7 to 8 meters in half an hour. But Earlier days, to put one single stick, it took whole days. So it was very difficult before. This is the way we used to fix the sticks in the glaciers. And as I have already told you that one stick forms the joining a combination of 7 to 8 sticks. And we used to go to the field 2 times in a year. One in July and another one in end of September. So in July, we used to go to the glacier and we used to put the sticks. And we take the reading, how much part is exposed, no? And in the end of September, again we used to go to the glacier and take the reading, how much melting happened in that particular year, in one abrasion season of 3 months. So this is how we are going to do the stick related work. Glacier velocity study. Actually, I have already told you the glaciers used to move downwards. And while putting the sticks, we used to take the length of the exposed height of the stick as well as the location of that sticks with the help of DGPS. And DGPS, it's a very accurate, all of you know, I think all of you know, it's a very precise, it gives us the accuracy level of in centimeters level. So while doing the survey, there is base and rover. While doing the DGPS survey, there is a base and rover. So base is fixed in the one permanent station, and rover we used to take wherever we have to carry the survey. This is, and stick finding task is very challenging. When in July we used to go to the glaciers and we put the sticks there. And in September when we go to the glaciers, it's very difficult to find out that particular stick because as we put the sticks, it will move, no? And sometimes it's all exposed, so its finding of sticks is very difficult. So this is the way we used to do the studies. And whatever vertical melting studies we have done, these are and the melting is very, very massive. As I already told you, we are studying the climate change. The purpose of studying is climate change. So what are the findings we have found through the field studies is that the rate of melting in most of the years the melting is very high. In 3 months, it's 3 to 4 meters average melting we found in the glacier. It's 3 meters in 2014, 4 meters in 2015, 3 meters between October 15 to June 16. In this year also we found about the average melting of 4 meters in 2024. So melting is very, very massive. And we used to take the DGPS reading, as I already told you. The displacement is also very, very massive. 16 meters in one ablation season, 25 meters, 20 meters is like that. And we are also monitoring the frontal part of the glaciers with the help of DGPS. This is the snout of the East Arkam Glacier. Snout is the point from where the water from the glaciers comes out. So this is the source of river Rongit. In Sikkim there are 2 major rivers, Tista and Rongit, and this Rakung Glacier is the source of river Rongit. This is how water comes from the glaciers. And the snout parts, it's also not intact, no? Being ice, it keeps on changing every time. As I already told you, we are working on South Lonak Glacial Lake from the year 2012. As all of you know, because of climate change, most of the glaciers are melting, and with the melting, lots of high altitude lakes are forming because of melting. And as you know, the glaciers glacial lakes are dammed by the moraines, and moraines are usually very loose, and it tend to burst if the size of the lake is going to increase. So this is the South Lonak Lake, location of the South Lonak Lake. It is located in the extreme northwestern part of the state. This is the way the South Lonak Lake has been increased. In 1976 it was a very small lake, In 1990 it has increased to a little bigger. In 2000 it was. This is the way the South Lonak Lake has been increased over the years. And likewise, not South Lonak Lake, there are other lakes are also increasing very fast. This is the way the South Lonak Lake has increased over the years. It was 18 hectares in 1976. It increased to 42 hectares in 1990. In 2000 it 67 hectares. In 2011 it became 109. In 2023 when it burst, it has attained the size of 180 hectares. And 1 hectare, for your information, 1 hectare, Paljar Stadium, all of you know, no? The size of Paljar Stadium is only 1 hectare. So the time when this lake burst, it was attained the size of 180 hectares. So size of 180 Paljar Stadium. This is the way how the glaciers melt. This is it's not of South Lonak Glacier. As the glacier melt, another area for the lake to increase as everything. So the melting is very when we see the photograph, it doesn't look much bigger. But when we analyze through the satellite image, it's a the carving of the glacier is very. It's a 100 meters to 70 meters, 60 meters to 45 meters. It's a very huge chunks of ice used to come to the lake through carving. So reaching South Lonak Lake is also a challenging job. We have to travel earlier days. Now we have to travel we have to trek almost for 4 to 5 days to reach the South Lonak Lake. Till Thangbu, we have to go to the car, and from Thangbu, in first day we have to go to the Mugutang by trekking in earlier days, but nowadays there is road accessibility is there. And from Mugutang, we have to travel to Janok 1. It takes another 1 day, and from Janok to Janok 2, it takes another 1 day, and from Janok to lake, it's 1 day. So its whole 4-day trek was required in earlier days, but nowadays road accessibility is there till Mugutang, and from Mugutang we have to go to the lake by trekking. And while going to this sort of high altitude lakes, lot of challenges are there. There is the lack of oxygen, it's one challenge, and lots of winds will be there, and freezing temperature will be there, and high altitude sickness, it will happen. It's common for all the people, whether you are from state or whether we are from the out of the state. Everyone faced, even the local people, they used to face the high altitude sickness. So walking in those areas is very tough and challenging. And in South Lonak Lake, we first visited in the year 2012. When I joined in 2009, and we used to analyze the satellite images, and the way the South Lonak Lake has been increasing, it makes us sometimes it makes us surprised. So we want to visit that lake. So in 2012, we first visited to that lake in the month of April. It was very snowing time. But once you start the expedition, lots of money we have to put on that. So we have to visit that lake even in the month of April. So we are very much curious why this lake is increasing so fast. So we decided to visit to the lake. First visit in 2012. So these are the group people we visited the lake. And when we visited the lake, it was very. It was still April. Still there was winter time, and the lake was frozen. So main objectives of our that expedition is to find out what kind of outlet is there. So how the water is flowing through the outlet, whether outlet is there or not. Because from satellite imagery, it was not so clearly visible. So we want to visit that lake too. Mainly our main objective was to find out the condition of the outlet. So we visited the lake in the month of April, and in July, there the scientist from ISRO, NRSC, it's a K. Govindaraj. He has published one research article of that South Lona, and in that article, it was and that article goes to the media. So media has published the news in such a way that it has created a lot of public panic in Sikkim. So everybody, and it was went to the national media and all the TV channels. They are showing this news. No, water bomb is forming in the northern side of Sikkim. It will going to take away all the areas of Sikkim, like water bomb is going to. Because in 2011 there was an earthquake. A lot of panic was there. In 2013, this paper, when it goes to the media, actually no, we are told not to bring those things, no, this kind of things, no, kind of the way the soft one and all the lake is increasing. We are told not to make it public, no. But when it went to the media, it came to know by all the people in Sikkim. So they visited our department frequently, asking what is the condition of the, because we are working on climate change and glaciers. Before that, so a lot of people, they used to came in our department to know this status. So what happened is that with that paper, it came to the media, and lot of pressure came to our department. So we have requested Government of India to do something for South Lonak Lake, and on our request, GST Government of India, they have formed one working group for study of South Lonak Lake, and that one meeting of that working group held in Gangtok, and that working group suggested both short-term and long-term studies for South Lonak Lake, and in their suggestion of working group, we are told to do the bathymetry as well as electrical resistivity survey of South Lonak Lake. So first study expedition held in 2014 for the bathymetric survey and electric resistivity survey. So bathymetric survey is done to know the volume of the lake, what amount of water is there in the lake. So through bathymetric survey, we used to get the actual amount of water in the lake. And resistivity survey is done to understand the what is the condition of the moraine that damming the lake. What is in the moraines? So underground features. To understand that underground feature, we used to do the electrical resistivity survey. And during that time, there was we do not have the systematic means to carry out the bathymetric survey. So we used a rafting boat. So doing a survey of the lake in the rafting in that altitude, it's a very challenging. Lots of this calving was there when we did the survey, and the lake is very deep. No, while doing the bathymetric survey, we used to put the ultrasonic depth finder machine. So when it has given the maximum depth we found is 131 meters, so deep. It is so very deep. So it's doing that survey is very challenging. But nowadays that USV vehicle has came. Now it's available in our department, so we do not have to do this kind of survey manually by going to the rafting boat. We just put that. It's just like video or it's a remote control vehicle, and this small boat is there. It is fitted with GPS as well as the ultrasonic depth finder machine. So we do not have to go to the lake manually. So this is the advantage nowadays we are having. So bathymetric survey gives this kind of results. So maximum depth we found is 131 meters. This is how we calculate the volume of the lake. And electrical resistivity survey we used to do like this. And one of the interesting thing of the shows much results. So again in 2018 we we visited that lake, and during that expedition, this is the portion. No? This portion is some blocking the water coming from the outlet. So in that expedition, we have joined with principal secretary, principal secretary from SSDME. So he also went to the lake, and he has decided to avoid this chunk of moraines which are blocking the lakes. So after our expedition, this portion has been removed from water. Some small, because it is very risky job to touch the moraines. No, it's a very fragile. Once you touch these moraines, it may hamper the stability of the moraines. No, so it is some risky job. So under his guidance, we have cleared a small portion, not all the portion, a small portion. We have removed the debris and put the pipelines. And after that, there was a COVID scenario came, no? So we have not make any expeditions during that period. And further in September 2023, one expedition went to the South Lonak Lake, and it was a combined expedition of state government as well as Swiss Development Corporation. So there was export from Switzerland also. So the Swiss export, they have installed that this early warning sensor there. But after 15 days of that expedition, the Lonak Lake has burst and caused tremendous flood. What has happened is that this is the photographs of 2 days ago, 26 September 2023, just before the flood, and this is the just after the flood. So what happened is that this whole chunk of mass, no, this is moraines, no, this just break and falls in the lake. So it has created a lot of huge wave in the lake, and it has washed the outlet, and it not completely burst, but some portion of it is not a complete burst. Whole water has not come from the lake, but only 24 meters of the lake flows out of the lake. So this is the damages it has caused. So lots of devastation it has caused in the downstream area. One of the main hydroelectricity project at Chungtham Dam washed away. So it has caused tremendous damages. So this is the area. Now 24 meters of lake level has been reduced in that water. Still, and in that, during the burst, the area of the lake was 180 hectares. After the burst, still there are 150 hectares still there in the lake. So damage, it has caused a huge damage, no? From some report, we have got the exact amount of, not exact, but it's near about amounts. It has the total loss was around 18,000 crores. It is a very huge damage for the state like Sikkim. So Tista Sikkim would have most of the damages was in the damages of the Chungtham Dam. It has cost of 14,000 crores. So damage was such a huge damage for a small state like Sikkim. So in September 2023 also, we have made another expedition after the burst of the lake, and again Swiss team went to that lake and installed that early warning AWS in the lake. It will give us the meteorological data as well as it captures some field photograph every day. So this is the photographs of the South Lonak Lake that every day that station used to provide us the photographs. So it is the photograph of 21 yesterday's photographs. So continuously we used to get the photographs. And again, after the South Lonak Coast, it has created a lot of awareness in the field of glacial flood, no? Because earlier the Govt, we are doing studies in South Lonak Lake from 2012 onwards, but nobody was listening, no? Government was not so much serious about this glacial hazard. But after this event, no? Because this Govt event, it's a, we can control if we do pre-mitigation activities, no? It is preventable disaster. Because we are working in South Lonak Lake since 2012, but in true sense, nobody was serious, no? But when it happens and when it causes lots of damages in Sikkim, state like Sikkim and all, so it has helped to create awareness or seriousness in the government. And now NDMA, National Disaster Management Authority, they have identified around 150 high-risk glacial lakes in entire Himalayas. And out of 150 glacial lakes, 40 lakes is located in Sikkim. So Sikkim is one of the most vulnerable state in terms of glacial hazard. So these are the locations of 18 glacial high-risk lakes in Sikkim. So once this report has came, we have started again working on all these 18 lakes, and recently we have completed the pre-field studies of 6 lakes. So this year we went to the high altitude lakes expedition for the 4 times, and the last expedition was held in the December. So this preliminary assessment we are using with the help of remote sensing. So we are doing the hazard assessment in this way. And what we are suggesting now is that the lake level, when we follow the lake level approach, no, it's very difficult. Reaching one lake is also itself is a challenging task. We have to 4 to 5 days in such a high altitude area. Oxygen level is very, very low. So everybody, even us from experts, even local people, they used to face the high altitude sickness, and reaching there is itself is a very big challenge, and walking there it's a very, very tough. One cannot able to, nobody can able to walk for more than 2 to 3 hours in such a high altitude area. So lake level approach, when we follow the lake level approach for the mitigation, it's not possible, because our experiences tell us that the lake level is not good for the very, very big lake in Sikkim. So what we are now suggesting is to watershed level approach. Watershed level approach is if we build some kind of check dams in the downstream areas, we can check the whole watershed. If we have to do the lake level approach, we have to visit each and every lake, and we have to put a lot of our efforts. No, a lot of money will require for individual lakes. But if we make some kind of check dams in the downstream area, we will able to check the whole watershed. No? There are lots of like this is South Lonak Lake. There is one North Lonak Lake is there. Khoracho is there, and many more lakes are. This Changsang Lake is also increasing at the rate of South Lonak Lake. This Changsang Lake, the Changsang Lake, it was not there till 1990. It started forming from 1990 onwards. So now it's more than 100 hectares. Changsang Lake is. Likewise, there is Guru Dongma. Guru Dongma, actually it is one lake, but behind Guru Dongma there is another 2 lakes is there. And out of 2 lakes, one lake is very, very new. It started forming only after 1990. But we used to refer as Guru Dongma A, B, C. A is the main Guru Dongma, which is visible from the roadside, and B and C is not visible. And C is the very, very new one, and C is now largest among 3 lakes. So melting is very, very high due to the impact of global warming or whatever we say. And if we follow the watershed level approach, if we prepare if we construct some kind of check dams there, we will able to prevent the flood we will able to check the graph-like scenario in one area. So now we are working in that. Also, their tunneling techniques are there. Some widening or deepening of the outlet, that is also there. But touching the moraines, it's a very risky. No, once you touch the moraines, there will be chance of higher rate of erosion in the outlet, and it may trigger the lake outburst. No, so it's depending on whatever approach we are following. So if we follow the lake level approach, it is less expensive, and if we follow the watershed level approach, it's expensive one. But it will solve the whole purpose, no? If we construct kind of check dams kind of downstream, no? It will check the whole thing, no? And before doing that mitigation measures, we have to do lots of field studies, no? We have to go to the lake, we have to take out the field whatever the data from the lake. We used to go to the lake. We have to check the what is the condition of the outlet, all that things, and we have to do resistivity kind of things, and we have to find out the volume of the lake. So lots of things has to be done before actual mitigation measures to be applied. Yes, sir.
So what is this dead ice?
Dead ice, it is old ice, no? Because once upon a time, it was that lake was covered by the glaciers, no? And as the whatever glaciers they come in contact with the direct sun rays and kind of things, it melts and it goes away. So whatever ice leave behind below the moraines, and it detached from the main glaciers, main glacier, and when it still there in the below the moraines, it's called dead ice. Actually, it's not. It is detached part of glacier. It is a detached part of glacier. That's why it's called dead ice.
So how does this affect the movement of moraines or glaciers?
It will not affect the movement of the glacier. It's already detached from the main glaciers, no? What is the problem is that if this dead ice located in the outlet area of the lake, and if in the long run dead ice it will melt, ultimately it will melt. Once the temperature, as we know, the global warming is happening, every year it's going hottest and hottest, no? This kind of rise in temperature will affect this dead ice, no? And if it is located in the outlet area, when it started melting, the dam which is supporting the lake goes down, no? And it may impact on the stability of that lake, and it may burst also later on.
Sir,
Yes.
so do you have the landslide inventory map of the recent years?
Landslide. Yeah, we are, as Miss Priya has already told, no, we are doing landslide inventory for the year 2023 using, we are first AI technology, we are using AI technology. Actually, it is a NRSA, National Remote Sensing Agency project, no? It's a national project. For Sikkim, we are doing. So whatever the method we have to follow, it comes from the Hyderabad, no? So they have prepared one model kind of things, and we put the post monsoon image as well as after pre-monsoon and post-monsoon image, and that AI technology, automatically it gives us the whatever landslide happened in that particular year. No? Yeah, we have for the 2023, but it is still in the final stage. It is not yet completed. From our part, it is completed. But we have on 28, 29, the team is visiting our center, and they will do EQC, and after 1 or 2 months, it will be finalized.
So can you get the data set?
Yeah, after finalizing, no? After we submitting, after I think 2-3 months it will be available. And that one is recent one. Yeah, you will definitely get. You will definitely get.
The most recent GSI has is 2022. So after that, there is no landslide.
No, yeah, but we are working on 23 images, yeah. It will be available very soon.
And sir, which tool you are using? Like Ms. Priya told that the tool of analysis is used for landslide detection. So
Yeah.
the name of the tool?
Actually, it's we are told that AI tool, no? But actually we do not know because they have just provided what is the technicalities behind that tool. It's only known by Android. But we are just following the guidelines. Whatever they say how to do the analysis, they just guide us and we used to do that.
And sir, Neeraj mentioned that climate change prediction has been done.
Yeah.
So which model is used for prediction?
Oh, that is that RCPs, no? I think you are talking about all RCPs, no?
That is initial scenario.
Yes, sir?
That is initial scenario, sir. That
Yeah.
is 8.5 and 4.5.
Yeah,
Initial
yeah.
scenario. This is not the final. That is asking which GCM is this.
Which model you have?
Prediction model.
Prediction model.
This is also this climate change vulnerability assessment done under the guidance of ISC Bangalore. There is Rabindranath sir, no? They have prepared some manual kind of things. So with their help, we did that assessment. And IIT, I think IIT Guwahati and IIT Mandi, they were the leading players in that. So whatever they have guided us to do, we just did. Actually, we used to do the national projects, no, of different agencies. So they used to give us the manuals how to do that kind of things, and we just following them. So if you want some more information, or no, we will ask to NRSA Hyderabad. No, they have provided us the tool, but I think they will give you. It's available to us.
Do you
I
use
think-
QGIS software and all also for
Yeah, some people from in our they use the QGIS also. Yeah.
And for the GIS, what satellite imagery do you use? Do you know?
It depends, no? It's a different satellite images
For
are there.
example,
Landsat.
ma'am talked about using list 3.
List 3. Yeah, list 3, list 4. It's depend. Now most of the time we used to use list 4 data.
Yes.
List 4 data we are using now.
Sir, in 2023, the GIS meeting has happened. By your department, is there any warning given for the people?
2023. No, what happened is that in 2016 we have installed lake level sensor. That sensor was developed by CDEC Pune. No, we have installed that in August. By December or January, it collapsed. No, what has happened is that there used to be huge calving in that place. No? There are huge chunks used to come by floating towards the outlet. No, might be that hit that platform, and when when that sensor stopped or it's giving the information, so we came to know that something has happened. And later when we visited that lake, we came to know that it is already collapsed. So we are not able to provide that kind of alert system that time. But luckily, there 2 kilometers below the South Lonak Lake, there is one base of ITBP. No, the ITBP people are there. So they are the first people who came to know about that glove has happened, and they have informed in their headquarters, and from their headquarters we got the information, and that has helped a lot in saving the life. Yeah. But now we are working on that installation of early warning system. But this early warning system is only helpful in saving the life. That is also very much important. But we will not able to save the infrastructure in downstream areas.
Man is mentioning that there are 70 number of AWS stations are installed.
But
You
yes,
are also showing in your the expert work that there are challenges in Sikkim is the lack of data.
yeah.
So I asking whether your department has stored the data of your 70 AWS or whether it is national data center it will be collected. Because when IIT director Dr. Govt Raha contacted that he has not only the substations, only 5-10 stations. Number one, my question.
Yeah.
And second question is that you are mentioning that you have some gauges, stream gauges are there, whether they are collecting the discharge. Your department are collecting the discharge data also?
No, sir. We have gauging stations for only for the Stratham Glacier. We have installed. We have some station there. We gauging station is only for the Stratham Glacier. There we are doing the field-based studies for the Stratham Glacier. No, it's we do not have that kind of station for all other all rivers. And that AWS, no, yeah, we have installed about 70 mini AWS, not a huge AWS. It's
When is that?
yeah.
In the year of
2 years, 2022. From the 2022, we have installed in almost 70 schools, no, in Sikkim. So what we came to know, we are collecting the data from those AWS stations, and we are even analyzing the data in our centers. But what we told, no, we have to, until if we have to give that data to the other institute, other organizations, no, first we have to validate that data with IMD, no, IMD Gantok. That need to be done. So we have now 2 years data with us for that.
IIT has only 12 or 14 stations in the Sikkim.
Yeah, IMD has very limited.
Very limited stations,
Yeah.
and the number of records also very less. And my another question is there, you are doing some climate change studies.
Yeah.
So for the historical records, so historical records you are collecting the data of your satellite based rainfall records or satellite based records or?
Yeah, satellite based also record we used to do, no. All the satellite data we have the year of 1976. 62 also we have, I think 76. We have all this data, satellite data is there.
Yeah. And last question is that you mentioned that for the mitigation of glove studies, there are check dams should be prevented such kind of catastrophic disaster. So after because of that glove studies, we also witnessed the severity of that flood, extreme hydrological events. So the failure of the Chunthang dam also at that happened. So do you really feel that that type of check dams really solving the problem of gloves after failure of Chunthang dams?
So there are some conditions, no. We are not suggesting this kind of check dam in the downstream areas. What we are suggesting to construct this kind of check dams in higher altitude areas where the surface is almost like plain area, very gentle surface is there, vast plain is there. So why not to utilize those areas, because there the velocity of the rivers is very less in compare with the downstream areas. So taking that advantage of the flat land in the high altitude area, if you go to I think most of some of you amongst you have visited the Gurudom area. It's a very flat land kind of area. So that kind of area is also there in the Dolma Sampa area. So we just want to take that advantage. There the velocity of river is very less. That's why we are saying there is some feasibility is there. So based on that only.
Thank you, sir.
Yeah.
Sir,
Yes, sir.
you had mentioned about the unmanned surface vehicle.
Vehicle, yeah.
So many lakes in Sikkim are considered sacred. So
Yeah.
do you need permission to use these?
It's very challenging because this particular year also, no, we have started our expedition for that preliminary field studies, and we have taken that kind of vehicle there. But once we reach the Lachung, the local people just agitate, no, because they have some thought that it is because of using of this kind of machinery that Lonak has happened, no. So they have this kind of thought. So we are prevented to do this kind of use this kind of machines. So we are stopped in Lachung for 4 to 5 days there. So after that also we are not allowed to do the, but we managed. Yeah, it's a very risky there, no?
So even drone they will not allow?
No, they have nothing to do with the drones, but army is there, no? Army is a concern for them. We have to take a lot of permission, no? If you want to use the drone in high altitude areas, in those defense areas, no, we have to take permission earlier, several days before doing that operations. And if you give after reaching to the fields also, no, we have to give another request, we have to make another request, and it takes 3 days to get the permission. And they will allocate some time frame, no, from that 8 to 10 a.m. you have to do. So they used to give the time slot, so we have to work on that time slot only. So they will give the permission, but it's very hard to get the permission from defense. Actually, it's some mandatory. They have mandatory to. They have prohibited to fly the drone up to 50 kilometers from the international border. No, if we consider that, whole Sikkim is restricted area.
Any question?
Okay, thank you.
Thank you so much, Mr. Pranay Pradhan and Ms. Priya Pradhan, for sharing your valuable insights with us today. We greatly appreciate you taking the time to speak with us and share your expertise. Indeed, it was a very informative session. Thank you so much. Thank you, sir. Thank you, ma'am. Now, I would like to request all of the participants to wait for some time for the tea.
I think before that we can have one group photo.